if you could see it. Okay. So 8.4, we're going to talk about solving quadratics and complex numbers. All right. So basically, what I'm going to do is talk about what a quadratic graph looks like. All right. We did a little bit of that last week on Thursday. I want to go back and do that again. Show you a couple different situations with solving them, and then we'll do the complex numbers. All right. So here's what I'm going to do is I'm going to start off by graphing, come on, some of these. Oops. All right, so I'm going to take a look at these. All right, we're going to graph these and look at their solutions. I'm going to have to do it in Desmo, so I'll try to leave that up there for a bit. And we'll come back to them. Okay, so the first one I'm typing in now. Okay, so there's our first one right there. Y equals x squared plus 4x minus 10. All right, if we solve this using the quadratic formula, from Thursday, we know that the answers are going to be where the graph crosses the x-axis. Okay, so this one has negative 5.7 and 1.7 as its two solutions. Okay? All right. Now I'm going to put the next one in. Okay, in this case, it crosses the x-axis right here at negative 2. But that's the only place it crosses at, just one spot. Now I'm going to put the next one in. Oh. Huh? Let me change this to, let's try an 18. That'd be easy to change. Okay. Now this one I changed it to an 18 instead of an 8. So at 18 I don't have anything crossing the x-axis. Alright, so then what we said was that was a no real solution. But what I want you to be able to see out of this is that we're either going to have two solutions, one solution, or no real solutions. Okay? Because here it never crosses the x-axis because it doesn't get down here. All right, but this one only had, the blue one only had one, the red one has two. All right. That's what I wanted you to see. So now I'm going to go back to this. Okay, I'm going to draw just a little picture here of what they look like. And this was an 18. It looks like that. All right, 2 real, 1 real. Yeah, this is a little bit of everything right here. And 0 reals. So, basically, what happens is that we can deal with these two things, but not this one. Okay? Mathematicians get bothered when something doesn't work out, so they have to try to figure out a way to fix that. All right? So, since this doesn't have any real solutions, they said, hey, we need to come up with something to fix that. So they did. And what they did is they came up with something called an imaginary number. And the imaginary number is symbolized by an I, and it's equal to the square root of -1. Now, imaginary numbers tend to cause folks some problems. I think it's just because maybe even the name kind of messes you up a little bit. You think, well, why would they call something imaginary when it's there? Okay, but that's what I is equal to. It's equal to the square root of -1. And what that does is that allows us to be able to get a handle on this problem here. Okay? We're not going to worry about it right now, but that's where the imaginary number comes from. So if I take all the real numbers that we have that you learned in Math 60, so you learned about all real numbers, every number in the number system, fractions, decimals, pi, decimals that go on forever, decimals that repeat, decimals that stop, all those things come together, that makes real numbers. Okay? Then if we union those with the imaginary numbers, I'm just going to go plus to put them together, with the imaginaries, together in one great big pot gives us the complex numbers. All right, so if I take all the reals and these new I numbers that we have, that makes up the complex number. So a complex number takes the form A plus B I, where A is a real number and B is a real number and I is the imaginary. So for example, 3 plus 2i is an imaginary number. All right? 4 is an imaginary number. 1/3 is an imaginary number. Or, excuse me, a complex number. Complex, I should be saying. Another complex number would just simply be 3i. Okay, so they can either be together or they can be separate. All right, those are all complex numbers. Okay, so complex number is every single number in the number system, all right, including the imaginary numbers. And that's, let's see, what are you going to have to do with them? Well, we're going to have to simplify them. So let's do that. Here's how that works. So if I take the square root of a -4, okay, now, wasn't not much long ago, a few weeks ago, I said, hey, you can't take the square root of a negative number, doesn't have, it's no real answer, you can't do it. Okay. Well, now that we know what imaginary numbers are, we actually can do it. And here's how we're going to give it. Here's how we're going to do it. So if we have a negative sign inside this square root, this negative is my I. So it's going to come out, all right, and take care of that. So then actually I'm going to have this. All right, so whenever I see that negative inside there, that's going to be my I. I'm going to bring my I out, okay, and then right over the square root is. Now I can take the square root of 4 because I know what that is. So this is going to be 2I. So whenever we have a negative underneath square root, even though I told you, we can't do that in chapter 7, well now we're in chapter 8 and they're introducing you to imaginary numbers, so now we can do it. Okay. We can do that.
If you write I2, is that incorrect?
It's not incorrect, it's just not appropriate. How about that? Okay, so what if we have the square root of negative 8? Well, before we said, oh, I can't do that because I got a square root, I can just leave it alone. Now we know about imaginary. So whenever we see a negative, I is going to come out in front. Now we got to break that down. Okay, we've done square root of 8 probably 10, 20 times. How does that break down, the square root of 8?
2i to square root of 2.
Right, because 2 times 4 is 8. 4 is a perfect square. That's 2, so the 2 comes out in front. This 2 goes inside here with the radical. 2i square root 2. Anytime you have a negative inside here and it's a square root, that becomes your I. Anytime. Okay, what if we have a square root of negative 10? All right, so, okay. Anytime I have a negative, there's my I. Can I break down the 10? No. There's no perfect squares that go into 10. So this is done. So it's okay to have I and a square root. They don't all have to work out nicely. All right, that's okay to have that. All right. Now there's operations on complex numbers, but I guess you don't do that till 95. Here all we're doing is solving and simplifying. So how about that? That's not too bad. We can get through that. Okay, now let's do the solving part. So remember, when we're solving a quadratic, you can have one answer, 2 reals, 1 real, or imaginaries. So let's go back up to that one we had up here with the 18. Let's see, where was that? There it is, 6x plus 18. So let's do that one. So we have y equals, I should say x squared. X squared plus 6x plus 18 equals 0. So we're going to solve that. All right? I already know it's going to be an imaginary because when I graphed it, did it touch the x-axis? Did this graph touch the x-axis when we graphed it? No, it did not. It was way up here someplace. Didn't touch the x-axis. That tells me that we're going to have 2 imaginary solutions. All right? Because it didn't touch the x-axis. So that's the key. All right, here we go. A equals B and C. We're going to use the quadratic formula. I bet everybody in here did that assignment knows the quadratic formula because you probably used it a bunch of times. How does it go?
Negative B plus B squared. B squared minus 4ac.
Yep, all over 2a. Very good.
Memorized now.
Yeah, sure. I knew you would. Okay, so now we're just going to put these numbers in where they belong. So I got a negative 6 plus or minus. I like to do that 36 in my head there. 4 times 1, oops, times 18 all over 2. I'm working this out by hand. I told somebody last week you could use decimals if you want to. 4 times 18, 72. Okay, so ordinarily if we had this, all right, in your assignments you probably said no real solution, which would have been a correct answer because it doesn't have a real solution. But now that we know about imaginaries, we can solve this. So we know that we have a negative, i's got to come out. Square root of 36, do we know what that is? 6. Okay, reduce, reduce. There it is. Negative 3 plus or minus 3i. Those are the two solutions that it has. Okay. They were imaginary. When we graphed it, it showed that it didn't cross the x-axis. Okay. So on your final, I'll guarantee there's going to be a problem where it's going to say solve it, and then you should be able to verify your answer graphically. So you should be able to go into Desmos, graph it, say, oh, hey, this one doesn't cross the x-axis, so I know I got imaginaries. It's got to be right. Okay? If it does cross the x-axis, then you got imaginary solutions. You know you're wrong someplace. Something went up.
So what is that just saying? Is that just saying that if that was crossing the x-axis, then we get a 3?
No. It's just saying that the answer is negative 3 plus or minus 3i. It's a complex, has complex or imaginary solutions. Okay? And so the deal is, if it doesn't touch the x-axis, then you know it's going to have complex or imaginary. It's going to have imaginary solutions. But you can't tell from this graph what they're going to be.
I had a question from last Thursday when I was watching your YouTube video. The Desmos part doesn't come up on there.
Oh, I know.
And so you said to enter something in the Desmos, you have to use parentheses.
Oh, yeah.
If you could show me that, that would be fantastic.
Sure. Be happy to. Let me show you that now. So, if we're in the Desmos and we want to enter this in, let me get rid of this, get rid of this, get rid of this. So let's say that we want to actually solve this out, right, in the quadratic formula. So what I told them is that the class last week, Thursday, you can do it by hand like we just did it, right? Or you can use Desmos, type it in, you get decimal answers. Either one's okay. All right. So if we're going to do it this way, then we have to go parentheses, negative 6. I'm going to use the same problem, plus square root 36 minus 4 times 1 times 18 divided by 2.
Should it be negative 6 plus or minus?
It should be plus or minus, but we can't put plus or minus in here. I can do plus, and then I'll go back and switch it to minus. But notice it says undefined because, again, we have a negative underneath the square root, and Desmos doesn't know how to deal with that. Okay, so Christine, that's how we did that. That's what I meant by that. Is you want to put a parenthesis here in the front and a parenthesis here in the end so that that whole thing gets divided. Otherwise, it's going to give you a wrong answer. Okay. And if I change this to a minus, I just click, like Jay says, make it a minus, boom, I still get undefined. Okay, doesn't work, but yeah, we got to look at both cases. Okay. So again, if you're using Desmos and you get undefined and you graph it and it doesn't cross the x-axis, you know you're probably right. But you have to work it out then. You just can't say, oh, it's undefined. You got to find the complex solution. Okay? Then you just got to go back to the paper and pencil or whatever you're using and work it out. Okay. Okay, so we'll try another one here. Okay, so we're solving all these. All right, so on the final then, it's going to give you a problem like this. It's going to say solve it. I'm not going to tell you how to do it. You can solve it using the quadratic formula. All right, which is probably the way you do it. but I don't think you're gonna be able to factor it. So then, remember A, B, C, you figure out what A, B, and C are, you get to this point, it's a 3-point problem, you get 1.5 points just for doing that, okay? All right, here we go. I already know what this is because you told me. All right, so let's work it out. Now, we could go to decimals right now, type it in, see what happens. If I get undefined, I know I got to work it out by hand. If I don't, then I get an answer, so I'm done. I just verify it graphically. X equals negative b. So let's see. What are we going to write? Negative 2. Plus or minus? Yep.
2 squared minus 4 times negative 3 times negative 10.
Outstanding. All over what?
2 times negative 3.
Okay. I do some of those in my head because it just, makes it a little bit quicker. All right, let's see. What are we going to get underneath here? We got 4 times 3 times 10, negative, negative, negative. So what's that going to be?
Negative 120.
Yep. So I'm going to have 4 minus 120. I got negative 6 on the bottom. I'm going to get a negative 116 there. Okay. Oh, there's my I right there, see? As soon as I get a negative underneath the radical or a square root, I know I get an I term right away. So I bring that out, throw that on the outside. And I think the toughest part for most people is going from here to here. For some reason, there's just a little bit of a struggle in understanding. When I have a negative, that means I have an I out in front. But the negative's now gone. Okay, you took care of it by using the I. Okay, let's see if I can do anything with the 116. I don't think that can be broken down. What goes in? Did you find one that goes in there? What? 2 and 29? Oh, is it 4 times 29 then? Is it really? Oh, how about that? Gosh dang it. And now I should reduce this, and reduce this. Okay. Now if we graph it, it's going to be something like this. It's not going to cross the x-axis. I don't know exactly where it's going to be, but it's not going to cross the x-axis. Okay. All right. Questions on solving those? Yeah.
How do you know if the parabola is pointed up or down?
How do you know?
Yeah, because you just kind of like throw a sketch up. And it's just
Yep. Hey, we're going to figure that out in the next half hour. Any other good questions? Could also have one like this. We did some of these. Okay. Here you probably wouldn't use the quadratic formula because you got to FOIL that out. We probably want to use the square root idea. I don't know if that had a name. I got a lot of 3's here. Okay, there again, got that negative in there for the square root. It's got to pop the I out. Add the 3 over. And of course, I forgot to put plus or minus out in front. Oof. All right. Not any different though. Same thing. Okay. Not any different. Anytime we have a negative underneath the square root, that's going to become your imaginary. All right, it's going to become your I. I really think that's all you're going to have to do is solve them. They're either going to be square rooting or you're just going to use the quadratic formula. They're not going to ask you to do anything else with those imaginaries. Okay, so then we're going to move on to 8.6, or 8.5, sorry. And again, this is what I would have probably done in the beginning, so we can know what we're talking about when we're graphing things or solving them. Okay. What am I looking at? Okay. All right, so let's look at the graph. Let's analyze the graph of a quadratic. And we've already seen some. They're called parabolas. Okay, we know we're going to get some sort of an arch shape. So what I'm going to do now is I'm going to go back into Desmos here, and I'm going to show you some of the characteristics of graph parabolas. If you want to, it probably wouldn't be a bad idea for you to kind of follow along with it. I think you'd enjoy that part. This is going to be what the activity is going to be about. It's going to have to do a lot with this. Okay? In fact, I might even give you a little exercise when we're practicing some problems on what the activity is going to look like. Yeah, I used to have that. Okay. So now I'm in the Desmos. So here's what I'm going to do. I'm going to type this. Y equals, come on. Oops, I got 2 of them. Y equals, and I'm going to hit this ABC, and I'm going to put an A in there, A, and then I'm going to go with a parentheses X, and then I'm going to go minus B, and I'm going to put a little squared right here, and I'm going to go plus, and I'm going to put a C at the end. Now when I do that, I get this add slider, ABC all. I'm going to hit all. Okay? And I get this thing. Alright? This is my basic parabolic graph. I'm either going to get a U-shaped graph. I'm going to leave A at 1, but I'm going to change this B to 0. And I'm going to change the C to 0. Okay. So I might even wait a little bit in case you want to follow along. So like I said, it'd be something you might want to use. So I type Y equals A parentheses X minus B parentheses squared plus C. It says add sliders. I said all. I made B 0 and C 0. So what we want to do is we want to explore what A, B, and C do to the graph. Okay, because Jay just asked the question, well, how do I know which way this thing's opening? All right, so let's take a look at A right now. I think I'm going to change this to a -5, and I'm going to change this to a +5. And I want to step it. I'll just leave it for now. Okay. When I slide this, that A value changes. Okay? So the A value is getting larger. what's happening to that parabola as I make the A value larger?
It widens or narrows the parabolas.
Okay, so you notice that it widens or narrows. When does it narrow?
When the A is larger.
When A is larger, okay? All right? So when A is larger, we're going to get a narrowing of that graph. And you said that it also widens. When does it widen?
When it gets smaller, when it gets lesser and lesser, closer to negative.
Okay, so when it starts to get into a decimal, sort of, okay, we're going to get a wider graph. Now, what happens when it's negative? It flips. Okay, so now we know the answer to your question. How do I know when it's opening up or opening down? Okay, and the same thing happens. You know, getting a narrowing, widening. All right. Okay, I'm going to move it back to 1 again. There we go. Oh, close. There we go. Okay, so we know what A does, and we'll write it down. I'll come back to it. Now let's take a look at B. What happens when we change the B value?
It
Change its expositioning. Okay, so if I change B to be a positive number, all right, it's moving it in the positive direction. What happens if we move it into the B becomes a negative? It moves it in the which direction? Negative direction. Okay, kind of cool. All right, I'm going to change B back to 0. C. What happens when I change C?
changes the Y value.
Changes the Y value. Okay, so it's moving it up and down. All right, so if I hit play on all these, you get all kinds of crazy effects on it. Okay, all right. Now, this point that we're looking at here has a special name. All right, let me get into a good spot. Oops, one of these I want to pause. Pause. There we go. This point right here is called the vertex. Okay, so if this parabola was upside down, all right, let me see if I can change A so it's negative. And I think I'll move C up a little bit. All right. So if I think of this as a, say, throwing a shooting a basketball, throwing a baseball, something that is launched. All right. The vertex is going to be the highest point. It's that exact point that it reaches there and it comes back down. That's called the vertex. Okay. Now it's easy to find the vertex in Desmos because you just graph it and you go to the top and it tells you what it is. Okay? That's really nice. It's not quite that easy without it. That point is the vertex. So in a parabola, there's two pretty important things about the graph of it. One of them is the vertex. Okay? Let me get this to a nice number. 2, and I don't care about that one, and let me change this to a 4. Okay, and I'm going to go x equals 2. Alright, x equals 2, which goes right through the vertex. That's called the axis of symmetry, because if I folded this over, it's going to match up. Alright, so the axis of symmetry goes right down the middle of the parabola. That's the other important thing that they talk about a little bit. It goes right through that vertex, divides that parabola because it's symmetric. Okay, called the axis of symmetry. All right. So, switching back to this, here's. Yeah, I'm gonna write it all down for you. Okay. So here's a parabola. All right. Axis of symmetry going right down the middle. That's what they call that. Axis of symmetry. Vertex is the point where it's going to top out at. Okay. And then if it's drawn the other way, vertex is there. Okay. Doesn't change. And what we found out is that this A, B, and C have an effect on the graph. Okay. Now, understand that this doesn't look like probably too many other parabolas or quadratics that you've seen. Okay? This is called vertex form. Okay? Because the B and the C tell you what the vertex is. And that makes sense because it moves it over and up. So the vertex is going to be B, comma, C. All right? When it's in vertex form. But only when it's in that form. All right. I want to move this over here a little bit. Okay, so let's review a little bit about what A does, and we're going to write this down.
It determines the direction of the graphic's opening and also its width or narrowness.
Okay, so let's say, I like that. I want to say something kind of like that. I want to say, as A becomes larger or large, I don't know what you want to put there. How about as A increases? Let's just do that. As A increases, what happens to our curve
It's wider.
as it increases?
Oh, it gets narrower.
Gets narrower. As A increases, narrower, I don't know if that's a word, narrower curve. Okay? All right, so as A decreases, what happens to our curve then as it gets smaller? As A decreases, what's happening? It's wider. Okay? Wider curve. And one other thing. What happens if A is less than 0? What happens to our parabola then? Flips. Good. So instead of being upright, it's down. Okay? All right, cool. What does B do?
It determines the parabola's position on the x-axis.
Okay? So it moves the graph in the x direction. We'll just say horizontally. Okay? Or you can say x direction if you want. All right? And it does that in B units. Now we have to be careful with that because this is a minus, okay? And I'll give you an example of what we're talking about, but you have to be aware of that because that's a minus. Okay, what does C do?
Moves the graph vertically.
Yep. Moves graph vertically. C units. Vertex form is the best way to describe or work with the graph of a parabola, okay? Because you can write the equation of or from the graph of one of these guys. Let's say I gave you an equation of parentheses x plus 1 squared minus 3. You can graph that without even using Desmos because you know the important things about this parabola. You know where the vertex is because I said up here that the vertex is BC. So whatever these two values are, that's where the vertex point is. So looking at this equation, what do you think the vertex point is? 1 and 3? Okay. Everybody agree? Graph it. Hop into your Desmos, graph it, tell me where the vertex is. Because we're going to get into Desmos soon anyway. Hop into it, tell me where the vertex is. Negative 1, 3, huh? Oh, negative 3, yep. So the actual vertex is negative 1, negative 3. It's down there. Which way is it opening? Up. That one we would have figured. Okay, so why is it negative? Why is it this rather than this? Well, because this is a plus, okay? And when we typed it into the sliders, we had x minus, which means that this number is actually a negative 1. So it's x minus a negative 1, which makes that a plus. So one thing we can do is think that this is always going to be the opposite. Okay? So if it's a minus 1 in there, then we know that it's actually a plus 1. If it's a plus like it is now, we know that it's going to be a minus. And then whatever that sign is going to be the same. Yes. Okay? Only for the x value. So now that you know that, if I just said, okay, here we go, we're going to graph this. I'm going to put a 1/2 here. I'm going to go x minus 2 squared minus 4. Right now, you're thinking, okay, I know where the vertex is. V for vertex, where's it at? 2 and negative 4, right. 2, negative 4, so there's the vertex. Which way is it opening, up or down? It's opening up. Okay, I got a positive number right there. It's a 1/2, so I know it's a little wide, so I'm going to sketch it. There it is. Okay, that's all you got. In vertex form, it's so easy to graph parabolas. All right. It's just really easy to work with. Okay. So when you having graphs, and I'm going to give you, like I said, I'm going to give you a little thing to work on during when we do some practice problems. Use vertex form. Okay, when you do your activity on Thursday, use vertex form. All right, it's going to be so much easier than the other forms. All right. The other forms look like this. This is called the general form. And you see almost all yours in your assignment are going to be in that form. All right? That form tells you nothing about a graph except the A's are always the same, so it would tell you whether it's opening up or down. But the B and the C you can't tell anything from those. Okay? The other form looks like this, which is what we say is factored form. Okay? And you've already written a bunch of stuff in factored form. All right? You've already done a bunch of stuff. And in this case, this C sub 1 and this C sub 2 are your x-intercepts. Okay? Those are your x-intercepts. But you're not going to have any assignment problems in factored form, so I'm not going to do a whole lot of stuff with that. But it's worth mentioning those are your three forms: vertex, general, factored. Okay? Any question on anything on the graph? Yeah?
So the general form you can only solve with a quadratic formula, like you can't put it into a vertex form?
Actually, you can put it into vertex form, but the technique to do that is not part of this course. Okay, you use a technique called completing the square, and it's in Math 95. Okay, and you can use completing the square, Jay, actually to solve quadratics. It's just not a very good way to do it. Okay.
All right.
Yeah.
I have a quick question. I know you said this at the under farther above the other form, what the vertex form. Why does it change from a negative to a positive?
So this is an x minus b, right? Okay. So as we said, b moves the graph horizontally b units. So whatever that number is how much it's going to move it this way. Okay. So if this is x minus 4, then b is 4, which means it's going to move it 4 over positive, because b is 4. Okay. If this is x plus 4, then that means this b would have to be a negative number in order for that to work. So if you have y equals x plus 4, remember that if it's x minus b, right? And the only way that can happen then is for b to be a negative 4, because you have an x minus negative 4 squared, and then goes to negative plus.
So,
Okay.
so this is kind of, I see the confusion. It's kind of weird.
Yeah.
We're usually used to being like, oh, that's negative b, but that's not even it. It's x minus. You know, it's not usually, but usually the symbols are in front. This time you have to remember it as x minus.
It's always going to be the opposite
Yeah.
inside those parentheses. Okay. And that, in more mathematics and graphs, that's very common in this situation, that it's always going to be the opposite. Okay? Kind of weird, huh? Yeah. So if you have x minus 1, then b would be 1, which means it's shifted over 1 unit that way, right? But if I have x plus 1, that means that b must be a negative 1 in order for me to get a plus here, because the form has a minus right there. See, that minus messes everything up for us. Right? That's the form. That's all because of the form. It's all because of the form. But once you get the idea that, oh, it's just the opposite of that, because even when this is a minus 1, okay, the opposite of a minus is a plus, right? And the opposite of this plus is going to be a minus. So you see, it's always the opposite when it's inside those parentheses. And that even goes back to this. When we were solving these, this one's been shifted this way. So its vertex is a negative one, whereas this one, the vertex is a positive one. So, true. Any other good questions on that? We're not done with these yet. We got some more stuff to do, but I'm gonna give you a break here. I'm gonna go get some water. Okay, so when we come back, I want to do a couple more things with section 8.5, show you 8.6, which is completely different stuff, and then we'll go from there. Okay? Okay, a couple more things on 8.5 as far as graphing the parabolas. So I tossed a couple of them up there, all right, and I had the equations in general form, but I want to make sure that we can do a couple things. One, we can find the vertex. We should be able to write these in vertex form right now. So let's see, I got one right here. All right, so let's do the purple one. Okay, y equals so tell the purple one up there. Okay, tell me something about A. Positive or negative? Negative. There we go. Okay, so why is it negative? Because it's upside down. All right, so the purple graph, U shape, okay, U's upside down, so we know that A is going to be negative. Okay? We don't know what A is, we just know that it's going to be negative. Okay? We're vertex, let's go get it. So in relationship to this graph, if I click on here and I put a point, okay, where's the vertex going to be?
Looks like negative 1.5 and 6.5.
Yep, right at the very top, right? That's where the vertex is going to be. So it's a negative 1.5, 6.5. So what do I write in here?
Plus 1.5.
Plus 1.5 squared, and then the C value is
Plus
6.5. Okay? All right, there it is. So if I type that in, it should go very close to that purple graph. All right, so if I go over here now and I say, okay, I want to type this in, y equals parentheses x plus 1.5 squared, come on, plus 6.5, oops, okay, I'm supposed to put a negative out in front and did not. See how close it is, okay? It would just be a matter of changing this to that 2 that's there, and it's right over the top of it, okay? So we got it. All right, let's try the other one now, okay? So let's try the orange graph. Let me hide this so we can get to it. Hide this. Okay. There it is. So what can you tell me about the A value for the y is a positive? Okay, it's going up. Okay, so we know A value's got to be positive. I don't know what it is, so I just want to know if it's positive or negative. Okay, I can guess from there. All right, what about our vertex? Let's go get it. So if we come down here and we estimate it, okay, I'm going to put a point on there. Looks like it's going to be right about here on the bottom. Okay. Negative 2, 12. So Ebony says, well, it's got to be a plus 2 in there. What is this going to be? Minus 12. All right. So you should, again, that's something that we want to make sure you can do. I'm going to give you a little activity on it tonight that you play with a little bit so you can do that, because your activity on Thursday is going to be writing some parabolas in vertex form. Okay? You can pick any form, but vertex is the easiest. The other part of 8.5 is what if I don't want to, what if I have this guy or this one and I want to find the vertex of it and I don't have Desmos, I can't graph it and I have to do something else. Is there another way? And the answer to that is yes. So if I come here, all right, I'm going to change the color for a second here. Finding vertex in general form. There is a way. Now you can always graph it, but again, if I don't have Desmos, how am I going to do it? So I have y equals x squared plus 4x minus 10. All right, I want to find the vertex of that. Here's what I do. I go negative b over 2a finds the x coordinate. All right, so a, b, I really don't need c, but I'll do it anyway. A, b, a is 1, b is 4, c is negative 10, just like the quadratic formula. That does not change. I'm going to go negative b, so that's negative 4 over 2 times 1. Negative 4 over 2 gives me negative 2. Now, the vertex is always a point, okay? So we have to understand the vertex is not the x value, it is a x and y value. Right? So we need both coordinates. And negative b over 2a tells us what the x coordinate was. It doesn't tell us what the y coordinate is. So we have to find it. But that's not so bad, because if I know what the x coordinate is, I can find the y coordinate by simply just putting x or negative 2 in for x. Okay, so if I take this negative 2, substitute it in for x, getting a little sloppy there, then I can figure out what the y coordinate is. And that's how you have to do it. Now, of course, if I had Desmos, I could just graph this and get that y coordinate, but you know, I don't know what certain situations are going to dictate for you. All right. That's negative b over 2a. So, on your assignment, it says, find the x-intercepts for the parabola whose equation is given. And then there's another one where it says, we're not even going to do those ones. Find the vertex. Okay, so one of them wants you to find the vertex, one of them wants you to find the x-intercepts. So now let's do the whole thing then. So now let's take one. Okay, we're going to find the vertex, and we're going to do it without using Desmos, and we're going to find the x-intercepts. Oh. Find the vertex. I use that negative b over 2a. A, B, C. Negative 1, negative 5, 8. Okay, so let's go for it. So here we go. Find the vertex. Negative b, so that's going to be a 5. 2 times a, that's going to be 2. That's a negative, so it's going to make that negative. Okay, there's my x coordinate of the vertex. Okay, take the opposite of b, it's -5, so put a 5. A is a -1, so I take 2 times that, I get -2. Alright, I think I'll change this to a decimal so I can deal with it a little bit easier. Now I'm going to substitute that in. And work it out. Okay. So let's see, this is -6.25 plus 12.5 plus 8. Unless I did something wrong. It's 20.5. 13.75, I think. No. Anybody get that? How much? 14.25. Okay. I was off a little. So then my vertex looks like that. Okay. Negative b over 2a, plug in, get your vertex. Alright, if you have decimals, you can use decimals, it doesn't matter to me. Now we got to find the x-intercepts. Alright, well the x-intercepts are no different than what the solutions are. We learned that last week. So, here we go. I'm going to use the quadratic formula, so I go back up to my a, b, and c, -1. Oh, I hope this has x-intercepts. 8. Yeah, it should. Okay. So we go 5 plus or minus 25 minus 4 times -1 times 8 all over -2. 5 plus or minus 25 plus 32 divided by -2 and 5 plus or minus square root 57 divided by -2. There's my x-intercepts. Okay, so the x-intercepts just come from solving on the quadratic formula. Alright. So you should kind of know how to do the negative b over 2a thing, probably. Find x-intercepts, use the quadratic formula. As far as the final goes, I'm not really too concerned about how you find the vertex of it. But if you take Math 95, whoever your instructor is, they might want you to use negative b over 2a. That's all of 8.5. Lots of stuff in there, I know. Yep. No problem. Okay. Here we go, last section. (8.6) talks about functions and what functions are. Okay? So what I'm going to do is let's take a look at this problem where we have, I always call the, don't know why, but Jake the plumber. Okay, charges 40 for a house call. And per hour. Plumbers make good money. All right. So we're going to make a little table here. All right. So he comes to the house, knocks on the door, says, "Hey, I got a plumbing problem." Okay. Charges you $40 to show up at your house and knock on your door. After that, he charges $40 plus the $50 he's worked on it for an hour. We're going to keep on going. And keep on going. This must be a very serious plumbing issue. Okay, this is a perfect example of a function. All right, now functions appear a lot more advanced mathematics. All right, so they're kind of setting the groundwork for you in this course on the functions and what they are. So this is an example of what a function is, and a function has a couple different things. First thing a function has is it has an input. So you're inputting values into a function, which can be an equation, okay? And it also has an output. The input values have a name, they're called the domain, and the output values have a name, they're called the range. All right? So the input values are the domain, output values is the range. So in this case, the hours would be the domain, that's your input, and the cost would be the range because that's the output. Okay? Domain and range. Now, here's what a function is defined as. It's a relation or correspondence. Try not to make this too mathy for you here. Correspondence between two values such that for each value in the domain there is one and only one in the range. So what this says is that for every value that is in the input set of numbers, the domain, there can only be one number paired with that in the range. Okay? So that's what the pure definition of a function is in mathematics. It has a domain and a range, input and output, and for each number in input, there can only be one number in the output. So if I come up and look at this, hours and cost, notice that for each and every hour there's only one cost. So if that plumber comes to your house, works on it for 2 hours and says, I'm done, he's going to charge you $140. All right? He can't just say, well, it could be 140. Oh, maybe it's 200. Oh, it could be 500. Well, let's pick one. All right? It's going to be 140. All right? There's, for each number here, there's only one number in the range. Okay? That's a function. There's a one paired relationship there. And number of times, if you're even looking on your final reviews, which I set up here by the way, they'll write functions using this little notation here. Okay, they'll use like a 1, 3, and a 2, 4, and a 3, 5, and a 4, 6. Okay? So, the domain is always the x values. Domain is x. And the range is always the y values. So, my domain in this case are all of these x values. 1, 2, 3, 4. And the range in this case are always the y values. 3, 4, 5, 6. Okay? Notice that 1 goes to 3, 2 goes to 4, 3 goes to 5, 4 goes to 6. Okay? For each number up here in the domain, there's just one number in the range. 1 goes to 3, 2 goes to 4, 3 goes to 5, 4 goes to 6. Let's say we have something like this. 2, 4, 4, 8, 8, 16, 16, 32. Okay, so the domain, again, the domain is all the x values. So what are the numbers that are in the domain? 2, 4, 8, 16. Okay, then here's the range. Ranges are y. So what numbers are in the y's? 4, 8, 16, and 32. Okay, and here's that pairing. Here to here to here to here. That makes it a function. As long as there is, again, one number paired with one number in the range, paired with one number in the domain, we're good to go. Two, 8, 2, 9, 2, 10, 2, 11. Tricky one, what's the domain? What's the x? 2. That's it. 2 every time. That's all there is. Range. What's the range? 8, 9, 10, 11. All right. So, in this case, 2 goes to 8, 2 goes to 9, 2 goes to 10, 2 goes to 11. So the question is now, is this a function? Why not? Right. 2 is paired with how many different numbers? 4. It's not a function. Okay? This is not a function. Alright? 2 is going to 4 numbers. It's not a function. Okay? As soon as it goes to a different number, it violates everything. So that makes it not a function, makes it a relation, actually. Alright. How about one like this? 1, 3, 2, 3, 3, 3, 8, 3. Okay? Here we go. What's the domain? And the range? 3. Okay? So here again, here's my pairing. Okay, a little different this time. Is this a function? Well, one no. So is it a function? For every number in the domain, there has to be one number in the range. Yeah. So yes, it is. Because 1 goes to 3, 2 goes to 3, 3 goes to 3, and 8 goes to 3. Yeah, they're all going to 3, but 1 is only paired with 3. Right? Okay. So yes, that is a function. All right. It's okay. Well, no, I mean, you could have a function that was just like 2, 2. I mean, that was it. Then you have 1, 2 in the domain and 2 in the range. That would be it. Okay? It more has to do with whether this domain number here, okay, is paired with how many numbers in the range. So, some people might think of this. Say, well, I got 2's here, so see how I have more numbers in the domain than they're the same number? Yeah. So that's kind of a dead giveaway there. That's not a function. Okay? Because there's how many? There's 4 numbers in the domain, but they're all the same. It just, yeah, vice versa. Okay. Vice versa. So, in a real world situation, there's a number of things that we could think of that would be functions. The plumber one's a good example of that because they're going to charge you a certain amount for working a certain amount of time. Okay? So, what about if we took a look at, what if we did this? What if we said we take a person, okay, versus their cell phone number? Is that a function? Okay, so if we have a person, me, am I paired with one number? Most likely, right? Yeah. Okay. Maybe I have a work number or something, but for me personally, yeah. So that would be an example of a function. Okay. What about you go downtown, you park at Smart Park? Time versus cost. How Smart Parks work? How do they work? They charge you for how much? Park? Haven't been there? Per hour? Per half hour? Okay? So, is this function then? So if I park for 10 minutes, well, let's say we park for 40 minutes. How much does it cost? Okay, let's just say, well, we'll say 1.1. Okay? I think it's 95 cents an hour, right? I think so, or maybe it's $1. We're going to say it's $1 an hour, so maybe they... Yeah, I think that's great. So that means they say you charge $1 for, right, because it rounds up, correct? Okay. What about for 50? Still $1. Okay. What happens for 90 or for 80? So it's going to be $1.50. Okay. 50 cents, $1 an hour. All right. So yeah, so 40 is related to 1. Right? They're going to charge you $1. So there you go. Is that a function? Right. Yeah. Right. Right. Okay. So yeah, that's a function. All right. Okay, so there's some different examples of things that are functions and certain examples for things that are not. Okay, as you go on. But that's the idea of a function. Okay. In this particular section, they're going to ask you to find the domain and ranges of functions that I wrote out up above there, and you did fine with that. The next thing they're going to want you to do is to evaluate some functions. So here's the notation that is used to describe a function. Okay? The F is just the name. Alright? Don't get hung up on that. It is just the name. This X and this X have to be the same. So what we do is we say this is F of X equals 3X plus 4. That's how you say that. F of X equals 3X plus 4. This X and this X have to be the same. Alright? Because the function related to that variable X has to be there. Alright? So you couldn't have F of X equals 3Y. It wouldn't make any sense. The variables have to be the same. You could have functions called G of X equals, and then whatever the formula is. Okay, it doesn't make any difference. H is common. F, G, and H are the most common ones. If we have D of T, then this has to be in terms of T. Okay? So whatever your function's name is, this variable and this variable's got to be the same, or else it doesn't make any sense. So if we're going to evaluate it, let's go back to the first one I wrote. Alright? What I'm going to do is I'm going to find F of 2. So wherever X is, I'm going to put a 2. And now I just got to work this out. That's how you evaluate them. It's very simple. We're just going to take that number, substitute it in wherever I see the variable, and work it out. Oops. So let's say we have x squared minus 3x plus 8. Okay, I want to find f of 1. So wherever I see an x, I'm going to put a 1 and work it out. Okay, that's how you evaluate them. Very straightforward. So there's a whole bunch of evaluations. I'm looking at them right now. They give you different functions with different rules or equations, and you just put those numbers in it. Okay. Yeah.
So, I must have missed it. You said for building a function right?
Yes. In this case, they're just going to give you one number pretty much. So it's going to be f of 10. So wherever your variable is, you would put 10. All right. One last thing. I'm going to switch out of this for a second. Go back into Desmos here again. The last thing that you need to know how to do about functions. Okay, I'm going to type this in. Go to a parabola. Okay, y equals x squared. All right, they want to know if this is a function. So, if I click on this, and hopefully you can see this. Yeah, I guess you can. All right, there is a bunch of numbers for my domain. All right. The question is for every single number on this graph that I go through, is there one x? Is there one y for each x? Yes. There is. All right? So no matter where I click on here, okay, negative 2.76 is the x value, 7.6 is the y, there's only one. Same thing as if I go over here someplace. It's the same thing. There's just always going to be that one number. So we say this is a function. All right? Now we have y equals x cubed. So the question becomes again, if I go around this curve, for every x, is there just going to be one y? Yeah, there is. Right? There is. Okay? Here we go again. This is square root, by the way. So again, for every x, is there one y? No matter where I click, is there one y? Yeah, there's only one. Okay? Only one. So, there's got to be something that has one that's not, or else I wouldn't be showing you this. Okay. Watch what happens here. If I go to 5, or pretty darn close to it, I get 0.5, I get 5, and I get 2.24, or pretty close to it anyway. But I could also come down here and go to that same number and get a different value. So here I have 2.26, here I have 2.26 for the same x. Alright, so this one we would say is not a function. Now, there's a way to tell, besides messing around and clicking and messing with points, okay? There is something that happens with this graph not giving me what I want. Let's see if I can go. Not giving me what I want. Okay. This graph, it has, if we take a vertical line and run it through, notice that the vertical line is going to touch in two spots. Whereas if I take and get rid of this one and go back to this one or this one or this one, and I run a vertical line through this, even though it's really, really steep, it's still only going to cross the vertical line in one spot. Same thing with the red one here, and the same with the green one here. Okay. That's called the vertical line test, and it tells you whether something is a function or not. So the vertical line test, there we go, vertical line test only got to write a few more things here. Pen, come on. The vertical line test will tell you whether a graph is a function or not. Because if a vertical line I don't care what you want to use, passes, intersects. I think I'll use intersects here. Crosses, touches, whatever word you want to use. And more than one point graph is not a function. So if I have a parabola like this, and I take a vertical line, and I pass it through, it touches in one spot, yes, is a function. But as soon as I have something that looks more like this, where I have like a C, the letter C, vertical line, nope, that's not a function. Hits it in two spots. Okay? That's with the vertical line test. So there's going to be some problems with that. All right, in your assignment and on the final, it's going to say, hey, is this a function or not? All right. And that's all there is in 8.6. It's a little confusing, the idea of a function. But you just got to remember, there's always going to has to be one y value for each x. Okay. Look for that one relationship. Any questions on the vertical line test?